I'm sure that most of us have heard the expression before, well, that program's just been loaded into memory, or I've got too many programs in memory at the moment. And we probably even have a reasonable idea of what those statements mean. But as C programmers, we actually require an in-depth knowledge of what those statements mean. We need to understand what it means to say that a program is running in memory. In this module, I'll do my best to explain that by use of a diagram. So imagine this big chunk in front of you is all the memory that represents one program running in memory. What will that memory actually contain? Well, it'll obviously contain, somewhere inside it, the machine code, the compiled program that is running, the steps, the object code of the program copied into memory. It'll also contain the data, the working variables, the information that we're actually going to be manipulating with the program. It's going to contain both those things, program and data. But is it as simple as that? Well, actually no, it's a little more complex than that. There's actually 4 different components to the memory. Thus you can see the diagram in front of you is broken up into 4 parts. And they are, in turn, static memory, stack memory, dynamic memory, and program memory. Let's have a look at each of those in turn and see what each of them are. Well, the first is static memory. Static memory contains all the global variables that you have created in your program, as well as all the variables that have been declared as static. In other words, local variables that retain their values between calls to a function. So this memory is created when the program starts. In other words, the lifetime of all these variables is the entire duration of the program. All static memory is initialized to 0 by default. You can, of course, initialize these variables to other values besides 0, and if you do, those initializations will happen before main actually starts running. All static variables, as I said, have a lifetime of the entire program, so they are only destroyed when the program ends. Secondly, we have stack variables. Stack variables are created when the block of code in which they are declared is run. Now that block of code is usually a function. We're talking about local variables here. And interestingly, we're also talking about function parameters. All of these are local variables and all of these are declared in stack memory. Variables in memory are never initialized, which means of course they contain random values until you manually initialize them yourself. And their lifetime is quite short. Stack variables are destroyed when the block that they are contained in ends. Thirdly, we have dynamic memory, which is actually the subject of this particular module. Dynamic memory is also known as the heap, and any memory that you use in the dynamic memory area is allocated only when the programmer requests it. Again, this memory is not initialized. If you obtain such memory from the operating system, you should assign a pointer to it so that you don't lose track of it. Finally, when you're finished using it, you should free it. In other words, you should give it back to the operating system so the operating system can use it for other programs as necessary. It's also interesting to note that if you neglect to free the memory, the operating system will free it automatically once your program terminates. Clearly, you have no further need for it at that time. Finally, different to all the other 3, we have program memory. Now in program memory you can't actually create any variables at all, because program memory is actually the object code of the executable file loaded into memory. In other words, it's just the programming steps, it's the source code compiled. It's not variables at all. It's the steps that your program needs to take in order to complete its task. You can never declare a variable in the program area of memory, nor can you attempt to modify this area of memory. If you do try and do that, your program will surely crash. Now, interestingly, this is quite an advanced little point here, but it is actually possible to assign a pointer into this area of memory. You can assign a pointer to certain functions, and then you can do very clever things with those pointers. And that's about the only thing that you can actually do with the program area of memory. But you'll have to refer to the chapter on function pointers to learn more about that. So there it is. Those are the 4 different types of memory, and what they are used for. You've already seen, I guess, the static memory and the stack memory, and in this module we're now going to learn more about dynamic memory.